Problem 125, valid palindrome. So basically, the problem asks us to check whether a string is a palindrome or not, and return true if it's a palindrome and false otherwise. And the way they want us to check the palindrome is whether it kind of reads the same from left to right as right to left. And when you read, obviously, you're not going to pronounce all of the punctuation marks, commas, colons, spaces. So we're going to ignore all of these white space and punctuation. And also when you read, you're not going to distinguish in pronunciation uppercase letters and lowercase letters. So they also suggest that we ignore letter cases, right? And basically with these with these considerations, we check whether a phrase is a palindrome. They have slightly stricter definition here, right? If after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward, that's palindrome. And they say alphanumeric characters include letters and numbers, okay? Okay, so got it. Let's, the first thing I'm going to do is copy this code to typescriptlang.org, typescriptlang.org, yeah? So the first thing I'm going to do is create a new string, letters, and in the string, I'm just going to take the original string S and get rid of all of the punctuation, all of the non-alphanumeric characters first. Yeah, let's do that. So let's take S and replace all. So I'm going to replace certain things with an empty character, right? So just remove things. And what I'm going to remove is, this might do it, right? This is non-alphanumeric characters. Now, is the definition of this non-alphanumeric characters the same as what they have? It's not exactly the same, though. So this, if I remember correctly, these are all numbers, uppercase, lowercase letters, but also I think the underscore is there, right? So the underscore is there. So this will match an underscore, right? So this is an alphanumeric character, including underscore, and this is non-alphanumeric character. So everything other than that, other than underscore, other than these, all of this. So underscore will not match. So we're not going to remove underscore, right? So we'll see. If they have rigorous tests, this will not pass. But let's keep it like this for now. Who knows? Maybe this will pass. And okay, so we've replaced all non-alphanumeric characters, at least in one definition of non-alphanumeric characters. Now let's convert everything to lowercase, yeah? To lowercase. Now, when we ignore casing, one way of doing that is just to convert everything to the same case, everything to lowercase or everything to uppercase, and then you don't have to worry about the case anymore, right? That's one way of doing it. Now, what we could do, so we have now this string called letters, and we have to now check whether this is exactly the same from left to right as it is from right to left. Okay. So why don't we reverse it and compare it to itself, right? So to reverse it, one way of doing it would be to split it with an empty string that gives you. So this is basically an array of all of these letters separately, right? All of the letters will be stored as separate strings, and that will be an array of strings or letters. Now, to reversed, right? That would reverse the array, and then join it back up with an empty string again, right? So we split this with an empty string, and then we joined it back with an empty string, but in the middle, we just reverse this resulting array. So that would reverse the string. Yeah. Now we can compare this to itself, to the original letters before reversing, and return the result of this comparison, right? So that should do it. Okay, let's copy everything to LeetCode. I mean, I'm still worried a little bit about this thing. Even if this passes, we should probably still, what the? All right, so this needs to be global. Right, called a non-global regex. Right, so I'm using replace all, and the whole idea here is that this should not be just the first match that is going to be replaced, but we need a global regular expression. So we match all of these, all of the non-alphanumeric characters, right? Okay, let's go. Okay, we passed this. Let's see how rigorous their tests are in terms of the right, so we didn't remove as predicted. Okay, so they have pretty rigorous tests. So this won't work. We actually have to say a range, yeah, a range of characters. So we'll specify a range of characters, and so negative range, right? From 0 to 9, from A to Z, and from A to Z. So this is basically a union of 3 different ranges. And this is a negation of the entire thing. So that whole thing is basically a range, which is now precisely what they want, right? Precisely, they said letters and numbers are alphanumeric. So this is all alphanumeric, and this is not alphanumeric. Okay, so we passed, we beat 74% in terms of speed. Not the most efficient solution, right? So, well, I mean, when you deal with normal strings, with the user input and things like that, it's not going to be millions of characters. So this is entirely fine. It's readable, it's short, it's understandable. But let's try to improve it a little bit. So once we got these letters, maybe we can do this slightly better. Instead of splitting it into an array, so that creates another array, unnecessary memory allocation, then we create another array by reversing it. Although we could reverse it in place, but still, and then we join it back. So all of these are necessary kind of actions that we could avoid. I mean, it's easy to write and imagine this is quite readable and understandable, but let's try something more efficient. So what I'm going to do here is imagine we already have this string, letters, right, where everything, all of the unnecessary characters were removed, and everything is being converted to alphanumeric, to lowercase. So everything's lowercase and no spaces, no punctuation, right? So why don't I take 2 pointers, I and j, right, from the opposite end of the string. And 2 pointers is great because this problem is about 2 pointers, right? So we are operating within, where are the topics here? So the topics are 2 pointers and a string. Well, obviously it's a string, but 2 pointers, right? So if you look at our thing, where is it? 2 pointers. So this is the first problem within 2 pointers. So why don't we just honor this and use 2 pointers? So I and j will move within the string from the opposite ends, okay? And we keep comparing a character at I position with character at the j position, right? If we ever find them to be different, we can instantly return false, because we know that we know for sure that this is not a palindrome if we find at least a single pair I and j where these are different. But if we can go through the entire string and we never returned false, then at the end we can just confidently return true. Oh, damn. It's not true. True like this. Yeah, that's true. Now, when should we stop? Right? When should we stop? Now, we should stop. So I and j, the last time they come here, right? So I and j, and then they will finally meet here, right? Well, it depends on whether you have odd letters or not. But I mean, we could come up with a very simple ending point. I mean, we should keep doing this until I is strictly less than j. After that, it's pointless. If they ever become the same, right? So if it's an odd number of letters, then at some point they will be stationed exactly at the same letter. Obviously, the same letter being checked with itself, it's never going to reveal, it's never going to be different from itself. So no point in checking a letter whether it equals itself. And even if I and j actually pass each other, then, well, we've already checked these bits. So there is no point in checking everything twice. So we should keep going until I is strictly less than j. Okay? So let I equals 0 and j equals letters length -1, right? And then keep going until I is strictly less than j. And in terms of iteration, plus I minus j, minus j, come on, okay? And as we said, if letters at position I is ever different from letters at position j, we instantly say false, not a palindrome. But if we successfully exit from this loop, that means we've never returned false. We never found any letters to be different. So here we can confidently say return true. It is a palindrome. Rid of this. So how about this? Now let's see. So we had what? 74% in terms of speed. Let's see. The memory, I'm not going to really bother. I mean, just running it on pretests. Okay, all accepted. So 74%, I'm going to submit it. 74 and 32, right? 74 and 32%. 74 for runtime and memory 32. Well, this is considerable improvement. 84 and 67 from 72 and 32. I mean, we could still improve it. So get rid of these regular expressions, get rid of this to lowercase. We could do that. I don't know if you're really into it. We could still make it slightly, but it's going to get ugly. I mean, because these things are really powerful and expressive, and to replace them with something, it could be faster and more memory efficient, but it would be not nice. Okay, let's try to do it. Let's try to do it anyway, right? Constant code of A, this is code of A equals take A car code at 0. Sorry. So this will be code of lowercase letter a. How about code of lowercase letter z? Car code at 0. So this is this will be code of this letter, right? Code of uppercase A, that's uppercase A, car code at 0. And then, what the hell did I do? This is A. This is Z. And we also need maybe here. So constant code of 0 would be 0 car code at 0, and code of 9 would be 9 character code at 0. So we got a bunch of character codes. Now what I'm going to do is let's start moving from, again, so I'm going to take ing. I'm not going to convert anything to lowercase and get rid of all of the punctuation. So what I'm going to do is this. So roughly the same idea, but I'm going to be moving in the original string, okay, inside the original string. And I'm going to keep ignoring all of the space and punctuation as we go. So for example, if say I is here, if I find that I is looking at a non-alphanumeric character, I'm just going to increment it and go to the next iteration of the loop and check again. Same thing for j. If it's looking at a non-alphanumeric character, I'm just going to decrement j and re-enter the loop. Okay. But if I see that both of them are looking at a alphanumeric character, then the first thing I'm going to do is convert both of them to lowercase, yeah, and then compare it. So roughly the same logic, and I think we'll see what happens. So first of all, should I write a couple of functions? So function is a digit, and here will be code. So I'm going to work with codes, okay, not with actual characters, because I have this function here, carCodet. So I can just read codes directly from each position, and I'm never going to be comparing letters, etc. So, and that way, if you want to convert this to C++, for example, it's going to be slightly more straightforward conversion, right? Is digit. So I'm going to return code of 0 less than or equal to code, and code is less than or equal to code of 9, correct? That's your is digit. You know what? I'm going to write this slightly. Is digit equals this. Yeah, sorry. Constant is lowercase. So code number. So how do we decide whether it's lowercase? Lowercase means it should be between A and between Z. This is your lowercase. Actually, uppercase should normally come before. Not a big deal, but is upper is code, and it should be between A and uppercase Z. Okay. So I have these. Why don't I also do another function called constant upper to lower? So uppercase to lower. It must kind of take a code of an uppercase character, right? I'm going to assume it's an uppercase because that's how I'm going to use it. And we're writing for efficiency. I'm not going to do a lot of checking of errors, etc. So, and basically what I'm going to do is return what? So code, and this is an uppercase, right? So let's minus code of A and add code of lowercase a. Okay, so if this was an uppercase A itself, this will cancel itself, cancel that, so 0, and then this will take me to a lowercase a. So I think you can see that this should convert a code of an uppercase letter to a lowercase letter, right? Because these are obviously the only thing we need, that these codes are in sequence. And of course they are. So we can use that. So we have these little helper functions here. Now let's write the same logic. So for let I equals 0, j equals s length minus 1, I is less than j. This is all universal logic here. Same thing. Plus plus I minus minus j. Basically same header, right? Now a little bit what? So if you know what? I'm gonna also do constant is alpha equals code number, and let's say it will say is digit code or is upper code or is lower code. Why not? Yeah, this is beautiful. So we could say if not is alpha, wait, let left character be S at the position of E and right character be S at the position of J. If not is alpha left, oh, sorry. What we need is code. So car code at I, so these should be codes, and then car code at J, correct? So if this is not an alphanumeric code, then we should increment I. No. So we would just increment I, plus plus I, else. Now, we should make sure that within this loop, there is nothing outside of this else. There should be nothing, everything should be else if, right? Because otherwise we need some sort of break after this. We should this should be the last operation inside this loop. We should never do anything else inside this loop. So after this, we should technically break, yeah? I don't think I can do this, right? I cannot do that. I could do this, right? I could do this. So, but I'm gonna not do it. I mean, because I'm gonna write it else if not is alpha right, then what? Minus minus j, right? Else. Now else that now here I'm kind of torn between using break or not using break. So else, we know that now we're looking at alphanumeric characters. We know that. Now the only thing we need to do is if is upper left, then let's change left to upper to lower of left. So that means we're going to convert left to lowercase. If is upper right, then right would be upper to lower right. Yeah? And now we're ready to actually make the comparison. If left not equal right, then we can instantly return false because they're not, these are not palindromes. And outside of the loop, we can return true, right? I think that is it. So you can change it a little bit again. I mean, let's run it like this. Copy this over to LeetCode. Copy this over to LeetCode. Run it on pretests. Okay, let's see what happens. Time limit. All right, of course. Of course, time limit exceeded because in here, If left, return false. Otherwise, we need plus plus I minus minus j, don't we? Because we only increment I, only change j if one of them is wrong. Yeah. So notice that we should not, if we notice that left is not alphanumeric, we shouldn't also look at the right in the same iteration. Okay, that would not be a good idea, right? We should come back to the loop and do this again. Yeah. All right, copy this to here and rerun it. And now submit. So 84%, 67, 84, 67, 84, 99. Okay, so we didn't really improve runtime, but in terms of memory, we just did not bad. Huh? Okay. Well, this is a decent performance for TypeScript, definitely. I mean, how did we beat 99%? Good. That's fine. Obviously, we could do better. I mean, if we get rid of all of these guys, I mean, but this is just pretty. We shouldn't change anything here. This is just decent. Okay, that's it.